This video, we are going to talk about fluids, density, and pressure. What are fluids? Fluids are basically substances which flow. And here we can find liquids are there which flow, and of course your air is there which flows. Now we will discuss the fluids based on their shape, shearing stress, and compressibility. As you know, solids have definite shape, but fluids, they acquire the shape of the container, liquids. This is true in case of liquids. Suppose you pour water into the glass, then the liquid will acquire the shape of the glass. So fluids generally, they don't have definite shape. Then what about shearing stress? We have seen in case of solids, suppose you have a block like this, solid block. If you apply a force here, this is called longitudinal force, and this area, suppose this is A, then F upon A will be your longitudinal stress. But solids can withstand horizontal force also. If you apply the force like this is called shearing force. They can withstand shearing stress. But in case of liquids, you cannot apply any horizontal force. They cannot withstand any horizontal force. So there is no question of withstanding shearing stress. Now another factor is compressibility. Solids, we know they are incompressible. Liquids, they are also incompressible. But in case of air, air is a compressible fluid. Like, suppose you have a piston, and here you have oil. Oil is a fluid. If you apply a force, then you can compress this to an extent only. You cannot compress it fully. Ultimately, this liquid will start showing its incompressibility property, and this property is used in mechanical engines. This you will study in your mechanical engineering. So this is about fluids. Now let us see what is density. Density is basically, density is denoted by rho. It is the ratio of mass upon volume. But here, one important fact is there. This mass should be uniformly distributed. Suppose you have a block. If it is a solid block, you can measure its mass and you can measure its volume. This will give you the density correctly. But suppose that block is having some cavity inside, then mass will be less, but it will have the same volume by dimensions if you measure. So in that case, the measurement of density will be wrong. You have error. So please note that it should be uniformly distributed throughout. In case of liquids also, the same thing is there. Suppose this is the liquid. If you measure its mass and volume, then you can find out the density. What is the unit of density? Density is mass upon volume. That means it is kg upon meter cube. This is the unit of the density. And what about its dimensions? Dimensions are m, l, minus these are the dimensions of the density. Now density is a vector quantity or scalar quantity. Of course, mass is a scalar, volume is a scalar, so it's a scalar quantity. Now, in case of water, at 4 degree centigrade temperature, the density of water is, it is 1000 kg per meter cube. Now, what about relative density? Relative density is the ratio of the density of any substance with respect to water density. Like density of iron is your 7 kg per meter cube. So its relative density of iron will be 7 point. So relative density is basically dimensionless. Correct? Here, one more thing I would like to tell you, that the density of water remains 1 even if you apply a pressure from 1 atmospheric to 50 atmospheric Fahrenheit. This remains almost 1. But in case of air, density of air is almost 1.21 at 1 atmospheric pressure. But if you apply pressure of 50 atmospheric unit, this is at 1 atmospheric unit. 50 atmospheric unit, then this goes up to 60 kg. Means I wanted to show you that air is a compressible fluid. Its density changes with pressure. So I hope the concept of density must have been clear to you. Now we will talk about pressure, which is very important. What do you mean by pressure? We have seen in case of solids, suppose you apply a force like this, and this is the area, then F by A, it is called longitudinal stress. But in case of liquids, you have, suppose one object like this, whose area is A, and if this force is F, then F by A, it is called pressure. At this point or on the face of that object. Now, pressure has got its own property. Like if you have liquid here, if you have a point here, then this P pressure will be same from all the directions. How this pressure is coming on this? Suppose you have an object like this. Then naturally, this pressure is coming. Suppose you have this water column above this face. So the pressure is coming due to the weight of this water column. Correct? So pressure is something like, and pressure, one more thing, it is always normal to the surface. So inside the liquid, definitely object is going to experience some pressure, and that pressure is due to the water column above that. In case of piston, suppose you have oil here, correct? And area of this piston is A. Then if you are applying a force F, then what will be the pressure inside? At this point, it will be F by A. So in case of fluids, basically, we call it pressure. So pressure, we have formula as P F by A, where F is force, A is area. So force is perpendicular to the area on which this force is there. Naturally, its unit will be Newton per meter square. This is the SI unit. And this Newton per meter square is also called Pascal. It is based on the French scientist Blaise Pascal. In the next video, we are going to see what is Pascal's principle. So unit, and what about its dimension? Dimension is, you can find out, Newton. Newton is your M, L, P minus 2 upon area. Area is your L square. So this will give you M, L minus 1, P minus 2. Correct? Now, this is also very important, whether pressure, this physical quantity, is whether this is scalar or vector. But as I told you, pressure can be in any direction. Means it is in all the directions. At any point, pressure is from all the directions, same, it is same. So means there is no distinguished direction for the pressure. So this is a scalar quantity. So this was all about fluid density and pressure.